All right. Angles and angle measure. All right, before we talk about an angle, we need to talk about a ray. A ray is part of a line with an endpoint weird thing about a ray is part of a line with an endpoint, but the endpoint is its beginning. That extends indefinitely in one direction. So if you have a line with points A, B, and C on it, here's your symbol for ray. It's just a arrow pointing one direction. So if we're going to talk about ray BC, ray BC starts at point B and it goes through point C indefinitely. This first letter of the description of the ray is the end point. And again, the end point of a ray is its beginning. It's where the ray begins. So ray BC starts at B, goes through C indefinitely in that direction. Ray BA starts at point B again, but now it goes the opposite direction. It goes through A indefinitely, that direction. So when you're describing a ray, the first letter in your description is the end point of the ray. The second letter in the description is any point that it goes through in the direction that the ray extends. We're going to say that ray BC and ray BA are what's called opposite rays. They have the same endpoint, and extend opposite directions. So ray BC starts at B, goes through C, extends up and to the right indefinitely. Ray BA starts at B, goes through A, extends indefinitely in this down and to the left direction. Ray BC and ray BA are called opposite rays. All right. There's a couple other rays in this picture that you need to be aware of. Does everybody see, or can you see ray CB? All right, ray CB. That would start at point C, wouldn't it? It would go through B indefinitely this direction. I'm putting the yellow on top just to not mix up all these colors and to show you that there's more rays in this picture. Anybody see another ray in this picture? Somebody describe one more ray in this picture and then we'll move on. Good, ray AB. Ray AB starts here at A, goes through B indefinitely in that direction. So there's your ray AB. Which brings us to angles. An angle is formed by two non-collinear rays. That have a common endpoint. So if you put a point on your piece of paper and then draw a ray that goes up and to the right, label that point A, and then put a point on your ray and label it B. And then if you put your pencil back on point A and you move down and to the right, put a point on that ray and call it C, you just drew an angle. This angle has some features that you need to be able to identify. Point A right here is called the vertex. This angle has two sides. It has side AB, which is right here, and it also has side AC. Right here. This angle has an interior, which is this region. All of this green region is considered the interior of the angle. And anything extending out and to the right, all of that is the interior of the angle. All of this other region, all of this space out here is all considered the opposite of the interior, which is that's the exterior of the angle. So there's a lot of features to an angle. None of them are difficult, but you have to be crystal clear on the sides of an angle, the vertex of an angle, the interior of an angle, the exterior of an angle. You have to be able to name an angle. When there's only one angle in question in the diagram that you're working with, you can name it by its vertex. Here's the symbol for angle. And then the point that represents the vertex. So there's only one angle in this picture up here, so we can name it angle A. When there's multiple angles, so let's put a point on your paper and we'll go up and to the right, out and to the right, down and to the right. And now let's call that vertex A again. And on this top ray, we can use point B. On this middle ray, point C. And on this bottom ray, we'll call it point D. Now we have multiple angles that have the same vertex. When you have multiple angles that use the same vertex, you have to use 3 letters to describe the angle. So if we want to describe, let's say, this blue angle right here. All right, this blue angle is called angle BAC. And you can also call it angle CAB. The vertex of the angle is always the middle letter in the description. There's another angle in this diagram, and it is, it's this green angle. That green angle has a couple of different names, and one of its names are CAD, and it could also be called angle DAC. And then there's the third angle in this picture. Yes, sir. This big angle around the outside, angle BAD. Angle BAD is one thing you can call it. The other name for that angle is angle DAB. And that's this one right here. Come on, give me a highlighter. There we go. Any questions on any of that we've talked about? All right, so in today's lesson, we're going to talk about three types of angles. The first angle being a right angle. And a right angle has the right angle symbol down at the vertex. And here's a little more, oh, what's the term I'm looking for? I can't think of it. This lowercase m in front of the angle symbol and then the vertex, you read this, the measure of angle A. Measure of angle A. And in a right angle, the measure of angle A is equal to 90 degrees. An acute angle. In an acute angle, the measure of the angle at the vertex, so the measure of angle A, if it were to be acute, is less than 90 degrees. And then you've got an obtuse angle. And an obtuse angle has a measure Let's do this. Let me move this over here a little bit. Let's say that 90 degrees is less than the measure of angle A, and angle A is also less than 180 degrees. So an obtuse angle measures between 90 and 180. All right, and then let's talk about one more angle while we're here, and that's a straight angle. And it just looks like a straight line. And in this case, the measure of angle A is 180 degrees. And that's this angle right here. It's basically a straight line. Straight line measures 180 degrees. Now, in some of your practice problems today, I think they're going to ask you to use a protractor to measure some angles. So we're not going to do that. I'm going to show you how to estimate angle measures. So let's take for let's put a line right here, a horizontal line. And then in the middle of that line, let's put a vertical line going out to the right. And then on your vertical line, put point A, put point B at this intersection, point C down here. On that horizontal ray, put point D. And then we're going to estimate some angle measures. All right, so we're going to say the measure of angle ABD. What would you estimate the measure of angle ABD to be? Good, 90 degrees. Doesn't it look like a 90-degree angle right there? If you were just going to pick a number without taking a protractor out. So if this angle ABD is 90 degrees, and we took that angle and we cut it in half, and we put point E right here, and you were asked to estimate the measure of angle ABE. Yes, sir. 45, right? Because if you cut that angle in half, it's going to be half the measure, so 45 degrees. If you go down here to the bottom, we have angle CBD. If you can picture angle CBD getting cut into thirds, it would look something like this. We could put, where are we at? E, we could put point F and point G right here. And if angle CBD was 90 degrees, then what could we estimate the measure of angle CBF to be? 30 degrees, because we took a 90 and we cut it into thirds, so 30 degrees. And if we try to estimate the measure of angle CBG, we're starting at C, angle CBG, that angle right there. Anybody want to give it a shot? Yes. Cami. 60 degrees, good. Because we cut that 90-degree angle into thirds. So if this angle's 30, and this angle's 30, and this third angle is 30, well then CBG takes up 2 of the 30s, and it's 60 degrees. All right, so that's how you can just use your eyes to estimate angle measures. Picture a 90-degree angle, and then picture how the angle they're asking you about is cut up in relation to 90 degrees. Does it look like half of 90? Does it look like a third of 90? You know, a little more than a third of 90 might be 32 or 34 degrees. And then a little less than half of 45 would be somewhere around 40 or 38 degrees. All right, you don't have to be exact, but you do need to be able to estimate angle measures. All right, a few more things to talk about, and then I'll give you some practice. Let's talk about congruent angles. Have the same measure. the symbol for congruent is the equal sign with the little squiggly line over it. And let's draw a horizontal line. We're going to put point A on the left of it, move over to the right, put point B. Now we're going to extend a ray from B down and to the left through point C. We're going to move to the right of point B, and we're going to put another point. We're going to call it D. And we're going to put a ray that starts at D and goes up and to the right through E. And then we're going to put point F on this line as well. Now, last week we talked about tick marks and how tick marks were a symbol that two segments were congruent. This symbol right here, this red little arc, called an arc mark. And this same arc mark here tells us those angles are congruent. Those arc marks mean angle ABC is congruent to angle EDF. One arc mark on an angle, any other angle with one arc mark on it means that they are congruent. They have the same measure. If this is 60 degrees, then angle EDF is 60 degrees. If an angle is marked with two arc marks, then any other angle with those two arc marks is congruent. So now we got a case where angle CBD is congruent to angle BDE. Can somebody tell me the angle measure of BDE with the two arc marks on it? Yes, ma'am. 120, very good. 120. How'd she come up with that 120? Yes. You remember this picture back here? Right here? That straight line has to measure 180, doesn't it? If the straight line has to measure 180 and this much of it is 60, isn't the rest the difference between 180 and 60? Okay, so that angle measure right there is 120, which makes this angle 120. Any angles that eventually form a straight line, the sum of those angles is 180. whether it's 2 angles, 3 angles, 4 angles, or 5 angles. Okay? We're going to say next that an angle bisector divides an angle into 2 congruent angles. An angle bisector divides an angle into 2 congruent angles. So if we have point A and we got ray AB and ray AC, if ray AD is an angle bisector, if ray AD is an angle bisector, then angle CAD is congruent to angle DAB. These two angles are congruent to each other. If DA is an angle bisector, then it divides this big angle into 2 congruent angles. If angle CAD is 60 degrees, then the measure of angle DAB would also be 60 degrees. That's what an angle bisector does. All right, so let's go with one more problem here, dealing with an angle bisector. Let's draw this figure first. So on the right-hand side of your paper over here, let's get a horizontal line. Up top, it's got point M. In the middle, it's got point K. Ooh, that's a bad K. Point K. And down here on the bottom, we want point J. And let's take KN out here. And KL over here. And what we're going to say, you guys caught up? KN. Ray, KN. Bisects. Angle JKL. The measure of angle JKN equals 8x minus 13. And the measure of angle NKL is equal to 6x plus 11. Find the measure of JKN. Now, don't panic. The first thing you want to do in this case is to get some information from the text description onto your diagram. All right? Kn bisects JKL. So here's Kn. It bisects JKL. So let's get the arc marks on there. Those two angles are congruent, right? Because Kn bisects that angle. So now what you're told is that the measure of JKN, J to K to N, this angle in here, this is 8x minus 13. The measure of angle NKL, starting at N, going to K, and then through L, is 6x plus 11. You need to find a measure of JKN. So look, this is where these highlighters work really good. You need to find the measure of JKN. Here's JKN. This expression. If these two angles are congruent to each other, and this expression represents the top angle, and this expression represents the bottom angle, we kind of did that yesterday with bisectors, right? How do you set up your equation? What do you know about those two binomials? If the angles are equal and the binomial represents the angle measure, what's 6x plus 11 going to be equal to? The 8x minus 13. You can now solve for x and substitute it to solve the problem. So subtract 6x from each side. Add 13 to each side. And then divide by 2. So 12 is equal to x. But you're not done, because you weren't asked to find x. You're asked to find the measure of JKN. So the measure of JKN is equal to 8 times 12 minus 13. 8 times 12 equals minus 13. 83 degrees. Does anybody have any questions on what we talked about today? Talked about a lot. Hopefully it's sinking in a little bit. All right, your practice for today. It's going to be out of the workbook, page 7. Page 7 and 8. All problems. What you don't finish in class, you're going to finish at home. You're going to have all these problems. You're going to work in class until you're done or until the bell rings. If at 11:44 you don't have all of this finished, you're going to finish it when you get home. Or you e-learners can finish it when you have your dedicated homework time. Be sure to check focus. Later today for a homework assignment. And make sure you have this assignment finished when you get to class tomorrow, because I may or I may not collect it at the beginning of class, and you'll be graded accordingly. Anybody have any questions? I would put it on a separate piece of paper, because when you get to some of these problems where there's a lot of work going on, you guys try to usually scrunch it into a really small area, and I'd rather you didn't do that. So just put your work on a separate sheet of paper. That way, if you have to turn it in tomorrow, you don't have to tear it out of your workbook. So here's today's assignment. And I'm going to say it again, make sure it's 100% complete when you get to class tomorrow. E-learners, if you don't have a question, you are excused from the meeting. And if I don't see or hear any questions in the next 20 seconds, then I'm going to close the meeting myself.